Hello and welcome to this 12th set of problems on AP, GP and HP. So let's get started. But as always, I will say that when I'm stating the problem, you should pause the video and try to solve the problem yourself. If you cannot solve the problem yourself, only then look at the solution. Now, problem 111 says that if S1, S2 and S3 denote the sum to n, where n is greater than 1, n terms of three sequences in AP whose first terms are unity and common differences are in HP, prove that n is equal to 2 S3 S1 minus S1 S2 minus S2 S3 is equal to divided by S1 minus 2 S2 plus S3. So we let D1 D2 D3 to be the common difference. S1 is n by 2 into 2 plus n minus 1 into D1. So this should be D1. D1 is equal to 2 into S1 minus n by n into n minus 1. And similarly, D2 would be 2 into S2 minus n by n into n minus 1. And D3 would be 2 into S3 minus n by n into n minus 1. Now it is given that D1, D2, D3 are in HP. So 1 by D2 minus 1 by D1 is equal to 1 by D3 minus 1 by D2. So upon substituting these values, we obtain this. And then we cancel out n into n minus 1. So we get this. And then we take LCM, we obtain S1 minus S2 by S1 minus n into S2 minus n is equal to S2 minus S3 by S3 minus n into S2 minus n. Now we cancel out S2 minus n from both sides and then we solve for n to obtain the desired result. Problem 112 says that find a 3-digit number such that its digits are in GP and digits of the number obtained from it by subtracting 400 form an AP. So we let the digits at 100, tens and units places be A, AR and AR square, and the required number is X. Then we can write X is equal to 100A plus 10A plus AR square. Now it is given that if we subtract 400 from this, we obtain a number Y, which is equal to 100 into A minus 4 plus 1 minus AR. Oops, this should not be 1 minus AR, this should be 10 AR plus AR square. Now, when we subtract this, these are in AP. So, we can see that A minus 4 has to be a digit. Okay. Now, A can lie between 1 to 9. So, A minus 4 will lie between 1 to 5. Okay. That is, A will lie between 5 and 9. Alright. See, why it will lie between 5 and 9 is because if you put 5 here, then it will become 1. So that is the minimum value of a digit for hundreds place in this case. Now maximum value can be 9 for A because it's a digit in X. According to the question, these digits are in AP. So A minus 4, AR and AR square are in AP. So 2AR is equal to A minus 4 plus AR square. We bring 4 this side to AR this side. We have A into R minus 1 whole square is equal to 4. That is R minus 1 is equal to plus minus 2 by square root of A. Now A and AR will be integers and R would be a rational number. So A must be a perfect square. Therefore, A is equal to 9. Now once we have found A, we can say that R is equal to 5 by 3 or 1 by 3. But R cannot be 5 by 3 because that will make AR 15. Which is invalid value for a digit. So R is equal to 1 by 3. That means AR is 3 and AR square is 1 and the required number is 931. Problem 113 says that if A, B, C be distinct positive numbers in GP and log of A with base C, log of C with base A and log of B with base A, B in AP prove that the common difference of the progression is 3 by 2. So we are given that ABC are in GP, so we let R to be the common ratio, then B is equal to AR and C is equal to AR square. Now we are given that this is in AP, so we can write that log of A by log of C, log of C by log of B, and log of B by log of A are in AP. So we substitute B is equal to AR and AR square, we obtain this. Now we write log of R by log of A is equal to X to get 1 by 1 plus 2x, 1 plus 2x by 1 plus x, 1 plus x in AP. Once we have this, we solve this to obtain this equation. Now once we have this equation, we can write that 2x square minus 3x minus 3 is equal to 0 because x is not equal to 0. Because if x is equal to 0, log of R would be 0, making common ratio 1, which is not possible according to the question because A, B, C are distinct. So we have this equation. Now, if you see these three terms, we can write 2d is equal to 1 plus x minus 1 by 1 plus 2x is equal to 2x square plus 3x by 1 plus 2x. Now we substitute the value of 2x square from this equation, that is 3x plus 3 plus 3x by 1 plus 2x, which will give us d is equal to 3 by 2. Problem 114 says that if p be the first of n arithmetic means between two numbers a and b, and q the first of n harmonic means between the same two numbers, prove that the value of q cannot lie between p and n plus 1 by n minus 1 whole square into p. So we let the two numbers be a and b, and since there are n arithmetic means between a and b, the common difference would be b minus a by n plus 1. Now p is the first arithmetic mean, which is a plus d is equal to n plus 1, n plus b by n plus 1. Similarly, for harmonic series, we can find out q as ab into n plus 1 by bn plus a. Now, from theory of equations, we know that if x lies between alpha and beta, then x minus alpha into x minus beta will be less than 0. But if it does not lie between alpha and beta, then it is greater than 0. Let me try to help you understand this. Suppose x is less than both alpha and beta, then this would be negative and this will also be negative. Both terms will be negative, making the product positive. And if it is greater than both, then x minus alpha and x minus beta both will be positive, making the product positive. But if it lies between both of them, then one would be positive and the other would be negative, making the product negative. Now we have q and p, so we can find q minus p, and we can find q minus n plus 1 by n minus 1 whole square into p. We can find these two as minus n into a minus b whole square by bn plus a into n plus 1. And the second one would be minus n plus 1 into a plus b whole square n by n minus 1 whole square bn plus a. Now we multiply these two. So here you can think that x is q and alpha is p and beta is n plus 1 by n minus 1 whole square into p. We multiply both of them and we obtain n square into a minus b whole square into a plus b whole square divided by n minus 1 whole square bn plus a whole square. Now all these squares will be positive. So the product is greater than 0. And that means q will not lie between p and n plus 1 by n minus 1 whole square into p. Problem 115 says that find a 3-digit number whose conjugative numbers form a GP. If we subtract 792 from this number, we get a number consisting of the same digits written in the reverse order. If we increase the second digit of the required number by 2, the resulting number will form an AP. So we have already solved a problem like this just now. So we let a to be the first digit and r to be the common ratio and x be the required number. Then we can write 100a plus 10ar plus ar square is equal to x. Now we subtract 792, we will obtain 100 into a minus 7 plus 10 into ar minus 9 plus ar square 1 minus 2. This is wrong. This should be 1 minus 2, which is equal to 100 ar square plus 10 ar plus a. That is, the digits are reversed in this case. The digits and the digits are reversed. Also, we see that the numbers are forming an AP. If we add 2 to the middle term, so 2 into ar plus 2 is equal to a plus ar square. That is ar square minus 2ar plus a is equal to 4. Similarly, we obtain r minus 1 is equal to plus minus 2 by square root of a. If you just remember, we had obtained the same value of r of the problem we solved earlier. Now also we will obtain that a minus c will be greater than or equal to 0. That is, a will be greater than 7. Now, like last problem, we argue that a and a are integers and r is a rational number, so a must be perfect square. So a is 9. So r is 1 by 3 and 5 by 3, and like last time, r cannot be 5 by 3 because ar will become 15. So ar is 3, ar square is equal to 1, and the number will be 931. Problem 116 says that an AP and a GP each has P as first term, Q as the second term, where 0 is less than Q, which is less than P. Find the sum to infinity S of the GP and prove that the sum of first n terms of AP may be written as NP minus n into n minus 1 by 2 into P square by S. So common difference of AP would be Q minus P, and common ratio of GP would be Q by P, which would be less than 1. So sum of infinite terms would be P by 1 minus Q by P, that is P square by P minus Q. So we write the sum of n terms of AP, which is n by 2 into 2p plus n minus 1 into d. We multiply, we get np plus n into n minus 1 into d by 2. We substitute the value of d and we multiply and divide by p square, and thus we obtain np minus n into n minus 1 by 2 into p square by s. Problem 117 says that if log of y with base x, log of x with base z, log of z with base y are in GP, and xyz is equal to 64, and x cube, y cube, z cube are in AP, find x, y, and z. So we write middle term square is equal to product of extreme terms, that is log x by log z whole square is equal to log y by log x into log z by log y. So log y will get cancelled, log x will multiply with numerator here in this side, left side, and log z will multiply with denominator on left side. So we will get log x whole cube is equal to log z whole cube, that is x is equal to z. Now if you substitute this value here, that is x cube plus y cube plus, sorry, x cube, y cube and z cube are in AP, then we will obtain that y is equal to either x, y is equal to z. So this means x, y, z all are equal. And now x, y, z are 64. So x, y and z all will be equal to 4. Problem 118 says that find all complex numbers x and y such that x comma x plus 2y comma 2x plus y are in AP, and y plus 1 whole square comma xy plus 5 comma x plus 1 whole square are in GP. So from the relationship of arithmetic progression, we find that 2 into x plus 2y is equal to x plus 2x plus y, that is 3y is equal to x. And then from the relationship in geometric progression, we find that xy plus 5 whole square is equal to y plus 1 whole square into x plus 1 whole square. Now in xy plus 5, we substitute the value of x as 3y, making it 3y square plus 5. And then we take root, we get plus minus y plus 1 into 3y plus 1. So this 3y has come because x plus 1 is now 3y plus 1. So once we take plus as one of the possible solutions, and once we take minus, we obtain three roots for y. 1 comma minus 1 plus minus 2 square root of 2I by 3, and x would be 3 times that, that is 3 comma minus 1 plus minus 2 square root of 2I. So that's what is our solution. Problem 119 says that find AP of distinct terms whose first term is 3 and second, 10th and 34th terms form a GP. So we let A to be the first term, which is equal to 3, and D to be the common difference of the GP. This should be AP, not GP. So 10th term square is equal to second term multiplied with 34th term. We solve this to obtain D is equal to A by 3, but A is 3, so D is equal to 1. So the AP would be 3, 4, 5 and so on. Problem 120 says that let A, B, C, D be 4 positive real numbers such that geometric mean of A and B is equal to geometric, there is spelling mistake, geometric mean of C and D, and the arithmetic mean of A square and B square is equal to the arithmetic mean of C square and D square, so that the arithmetic mean of A to the power n and B to the power n is equal to the arithmetic mean of C to the power n and D to the power n for every integral value of n. So since the geometric mean of AB and CD are equal, so we can write that A square root of AB is equal to square root of CD. Arithmetic mean of A square B square is equal to arithmetic mean of C square and D square. So we can write A square plus B square by 2 is equal to C square plus D square by 2. So we square the geometric means, we get AB is equal to CD, and we get A square plus B square is equal to C square plus D square. Now if we multiply geometric means by 2 and subtract and add respectively, then we will obtain A minus B whole square is equal to C minus D whole square, and A plus B whole square is equal to C plus D whole square. Now from these two we can arrive at the conclusion that A is equal to C and B is equal to D. Once we have established this fact, we can say that the arithmetic mean of A to the power n and B to the power n is equal to the arithmetic mean of C to the power n and D to the power n for every integral value of x. With this, we come to the end of 12th set of the problems, and next video will have 13th set and so on. There are still some 50, 60 odd problems are there, and then this will be complete. That is arithmetic progression, numeric progression, and harmonic progression will be complete. I hope that you have found this video useful, and if so, please subscribe to the channel and like the video. And when you will do that, it will reach to more people, and more people will benefit from this. Also, if you have a question or comment, or you want to say something, then please use the comment box to do that. And thanks a lot for watching the video. Bye.